Stars can literally explode without warning. Imagine this. You wake up tomorrow, and the sun, the eternal guardian of life, has vanished into a violent bloom of fire. No warning. No time to say goodbye. Just obliteration. For centuries, humanity has looked up at the night sky and seen permanence. Stars as symbols of eternity, guiding sailors, inspiring poets, anchoring our fragile sense of stability. But what if that stability is an illusion? What if the cosmos is a ticking time bomb, and we are living on borrowed time? Tonight, we unravel a truth so unsettling, it will haunt you long after this video ends. Stars can explode without warning. Not in 1,000 years. Not in 1,000,000. But now. This very second. The universe is not a gentle cradle, it is a battlefield of forces beyond comprehension. Every star you see is a nuclear furnace, a delicate balance between gravity and fusion. And when that balance falters, the result is catastrophic. A supernova. A cosmic scream so loud, it echoes across galaxies. But here's the part that will twist your mind. Sometimes, these explosions give no sign. No precursor. No whisper of doom. Just silence, then annihilation. Think about what that means for us. For Earth. For everything we love. We live under a sky filled with ticking bombs, and we don't even know which one will go off next. Science tells us stars die in predictable ways. At least, that's what we want to believe. But reality? Reality is chaos disguised as order. There are stars right now, in our galactic neighborhood, primed for detonation. And when they go, they will unleash energy so immense, it could sterilize entire solar systems. This is not science fiction. This is astrophysics. This is the truth we've been too afraid to confront. So tonight, we dive deep into the psychology of cosmic terror. Why do we cling to the illusion of permanence? Why does unpredictability terrify us? And what happens to human civilization when the stars we worship betray us? Brace yourself, because by the end of this journey, you will never look at the night sky the same way again. Let's begin. The illusion of cosmic permanence. For as long as humanity has existed, we have looked up at the night sky and seen permanence. The stars, scattered like diamonds across the velvet darkness, seemed eternal, unchanging, unwavering, a silent promise that the universe was stable. This illusion of cosmic permanence has shaped our myths, our religions, and even our sense of identity. Ancient civilizations worshipped the stars as gods, believing them to be immortal fires burning in the heavens. The Egyptians aligned their pyramids with Sirius, the dog star, as if its brilliance would never fade. The Greeks wove constellations into stories of heroes and monsters, assuming those celestial patterns would endure forever. Even today, we speak of stars as symbols of eternity, wedding rings engraved with constellations, poems whispering of love that lasts as long as the stars shine. But permanence is a comforting lie. The truth is far more unsettling. Stars are not eternal. They are living entities, governed by the same laws of birth, life, and death that bind all things. And like all living things, they can die, sometimes violently, sometimes without warning. This chapter is about that illusion, the psychological scaffolding we've built around the idea of cosmic stability. Why do we cling to it so desperately? Why does the thought of stellar impermanence terrify us? To answer these questions, we must first understand the human mind's relationship with the infinite. From the moment we became aware of the cosmos, we sought patterns. Predictability. Certainty. The night sky offered that in abundance. Stars appeared fixed, their positions unchanged for millennia. To early humans, this was proof of order in a chaotic world. Seasons shifted, rivers flooded, empires rose and fell, but the stars remained. They became our compass, our calendar, our silent guardians. Psychologists argue that this reliance on cosmic permanence is rooted in our fear of mortality. We crave anchors, symbols that outlast us, because they soothe the terror of impermanence. If the stars endure, perhaps something of us endures too. This is why cultures across the globe projected immortality onto the heavens. The stars were eternal because we needed them to be. But science shattered that illusion. In the 20th century, astronomers discovered that stars are not static. They are dynamic, evolving entities. They are born in clouds of gas and dust, ignite in nuclear fusion, and eventually exhaust their fuel. Some fade quietly into white dwarfs. Others collapse into neutron stars or black holes. And some, perhaps the most terrifying of all, end their lives in cataclysmic explosions called supernovae. Here's where the illusion becomes dangerous. We assume these deaths are predictable. We imagine warning signs, gradual dimming, instability, signals that give us time to prepare. But reality is crueler. Certain stars can explode without any observable precursor. One moment, they are serene beacons in the night. The next, they are titanic blasts of energy, outshining entire galaxies. Consider Betelgeuse, the red supergiant in Orion. In late 2019, it began to dim, sparking speculation that it might soon go supernova. The world watched, fascinated and fearful. But Betelgeuse stabilized, reminding us that even our best predictions are fragile. What if another star, one we're not watching, detonates tonight? What if the light from that explosion is already racing toward us at the speed of light, destined to arrive tomorrow? This uncertainty gnaws at the human psyche. We are creatures of control, yet the cosmos operates on scales that defy comprehension. A star's death is not just an astronomical event, it is a philosophical earthquake. It forces us to confront the fragility of existence, not just our own, but the fragility of everything we assume is permanent. The illusion of cosmic permanence is comforting because it shields us from chaos. But chaos is the universe's default state. Stars are not eternal sentinels. They are ticking bombs, their lifespans measured in millions or billions of years, a blink in cosmic time. And sometimes, those clocks run out without warning. In the chapters ahead, we will peel back the layers of this unsettling truth. We will explore the science of stellar death, the monsters lurking among the stars, and the psychological toll of living under a sky filled with silent threats. But before we move forward, pause and look up. See those stars? They are not promises. They are possibilities, possibilities of beauty, of destruction, of endings we cannot predict. The illusion is comforting. But illusions always break. And when they do, the universe reminds us of its most haunting truth. Nothing lasts forever, not even the stars. The science of stellar death. Stars are not eternal flames. They are engines of creation and destruction, governed by the laws of physics that shape the cosmos. To understand why stars can explode without warning, we must first trace their life cycle, from birth to death, and uncover the violent processes that lurk beneath their serene glow. Every star begins its existence in a stellar nursery, a vast cloud of gas and dust drifting in the interstellar void. Gravity, relentless and patient, pulls these particles together until a dense core forms. As the core contracts, temperatures soar to millions of degrees, igniting nuclear fusion. Hydrogen atoms fuse into helium, releasing energy that pushes outward against gravity's inward pull. This delicate balance, fusion versus gravity, is what keeps a star alive. For billions of years, this equilibrium holds. Our Sun, for instance, has been burning steadily for 4.6 billion years and will continue for another 5 billion. But this stability is temporary. Eventually, the hydrogen fuel runs low. The core contracts further, temperatures spike, and new fusion reactions begin. Helium into carbon, carbon into heavier elements. The star swells into a red giant, its outer layers expanding as its core becomes a furnace of unimaginable heat. Here is where the story turns violent. When a massive star, many times larger than our Sun, reaches the end of its fuel supply, gravity wins. The core collapses in a fraction of a second, triggering a supernova, an explosion so powerful it can outshine an entire galaxy. In that instant, the star's outer layers are hurled into space at thousands of kilometers per second, scattering elements that will one day form planets, oceans, and life. But why do some stars explode without warning? The answer lies in the complexity of stellar interiors. These are not simple spheres of gas, they are layered structures, each shell burning a different element. Instabilities can arise deep within, hidden from our telescopes. A sudden shift in fusion rates, a collapse of the iron core, or the onset of parainstability can trigger a catastrophic failure without any visible precursor. Astronomers monitor stars for signs of impending death, changes in brightness, spectral shifts, irregular pulsations. Yet these indicators are not foolproof. Betelgeuse's dimming in 2019 sparked global speculation of an imminent supernova, but the star recovered. Conversely, some supernovae have erupted from stars that appeared perfectly stable days before their death. The cosmos keeps its secrets well. Consider the phenomenon of gamma-ray bursts, the most energetic explosions known. These bursts, lasting mere seconds, release more energy than our Sun will emit in its entire lifetime. They are thought to occur when massive stars collapse into black holes, their magnetic fields focusing jets of radiation across space. If one of these jets were aimed at Earth from a nearby star, it could strip away our atmosphere and sterilize the planet in an instant. And we might never see it coming. This unpredictability is not just a scientific puzzle, it is a psychological nightmare. We imagine the universe as orderly, governed by predictable laws. But stellar death reminds us that chaos lurks beneath the surface. A star's serene glow can mask a core on the brink of collapse. The night sky, which we trust as a symbol of permanence, is in fact a gallery of ticking bombs. The mechanics of supernovae are awe-inspiring and terrifying. When the core collapses, temperatures soar to billions of degrees. Neutrinos, ghostly particles, flood outward, carrying energy that helps blow the star apart. Shock waves ripple through its layers, tearing it asunder. In the aftermath, what remains depends on the star's mass. A neutron star, a city-sized object so dense that a teaspoon weighs billions of tons, may linger. Or, if the star was truly colossal, a black hole forms, swallowing light and matter into an abyss from which nothing escapes. And yet, amid this destruction, creation thrives. Supernovae forge the heavy elements, gold, uranium, iodine, that make planets and bodies possible. Every atom of iron in your blood was born in a dying star. This duality, death as a prelude to life, is the cosmic paradox that defines existence. But do not let this poetry distract you from the terror. The unpredictability of stellar death means that even with our most advanced instruments, we cannot guarantee safety. Somewhere in our galaxy, a star may already be collapsing, its final scream racing toward us at the speed of light. We will not hear it until it arrives, and by then, it will be too late. In the next chapter, we will meet the monsters among stars, the hypergiants, the Wolf-Rayet titans, the ticking time bombs that haunt the Milky Way. They are beautiful, they are deadly, and they remind us of a truth we cannot escape. In the universe, permanence is an illusion, and chaos is king. The monsters among stars. They are the titans of the cosmos, the monstrous stars that defy imagination, burning with such ferocity that even the laws of physics seem strained under their weight. These are not the gentle suns that cradle life. These are killers, ticking bombs of unimaginable power, lurking in the darkness like predators waiting for the perfect moment to strike. Among these cosmic beasts, the Wolf-Rayet stars reign supreme. Stripped of their outer layers, these stars are raw, exposed cores blazing at temperatures exceeding 200,000 degrees. They roar with stellar winds so violent they eject mass at millions of times the rate of our Sun. Each gust carries away matter that could form entire planets, flung into the void like shrapnel from a celestial explosion. Wolf-Rayet stars are the final act before catastrophe. They are dying giants, their cores fusing heavier and heavier elements in a desperate attempt to stave off collapse. But the clock is ticking. When the fusion furnace falters, gravity will crush the core in an instant, triggering a supernova, or worse, a hypernova, a detonation so fierce it can unleash gamma-ray bursts capable of sterilizing entire regions of a galaxy. Then there are the hypergiants, the leviathans of stellar evolution. Imagine a star so vast that if placed at the center of our solar system, its surface would engulf Jupiter. These monsters burn through their fuel with reckless abandon, living fast and dying young. Their lifespans are measured not in billions of years like our Sun, but in mere millions. They are cosmic fireworks, dazzling and deadly, destined for explosive ends that defy comprehension. One such hypergiant, Eta Carinae, lurks in our galactic neighborhood. It is unstable, volatile, a star that has already survived one colossal eruption in the 19th century, a blast so bright it briefly became the second most luminous object in the sky. Astronomers believe Eta Carinae is a prime candidate for a future hypernova. When that day comes, the energy released will be so immense it could reshape the interstellar medium for thousands of light-years. But the monsters do not stop there. Luminous blue variables, magnetars, and other exotic stars populate the cosmic bestiary. Each carries its own brand of terror. Magnetars, for instance, are neutron stars with magnetic fields trillions of times stronger than Earth's. A single magnetic flare from a magnetar could fry electronics across a planet, rendering technology useless in an instant. What makes these stars truly terrifying is not just their power, it is their unpredictability. We cannot forecast their deaths with precision. A Wolf-Rayet star might linger for thousands of years, or it might explode tomorrow. A hypergiant could appear stable, then collapse without warning, unleashing a blast so intense it outshines entire galaxies. Imagine the psychological weight of this truth. We live under a sky filled with predators, each capable of annihilation on a scale beyond human comprehension. And yet, we gaze at them with wonder, oblivious to the danger. This duality, beauty masking horror, is the essence of cosmic terror. Astronomers study these stars with relentless focus, probing their spectra, monitoring their brightness, searching for clues. But the universe guards its secrets well. For every prediction, there is a surprise. For every model, an anomaly. The cosmos is not a machine, it is a living chaos, and these monsters are its most violent expression. In the next chapter, we turn our gaze inward, to the star we know best, our Sun. Could it betray us? Could the very source of life become the agent of our destruction? The thought seems absurd, comforting in its impossibility. But as we have learned, in the universe, impossibility is often just a word we use to hide from fear. The Sun, could it betray us? For billions of years, the Sun has been our unwavering guardian, a blazing sphere of plasma that sustains life, drives our climate, and anchors our sense of cosmic security. It is the heart of our solar system, the giver of warmth and light, the silent constant in a universe of chaos. But what if that constancy is an illusion? What if the very star we depend on could betray us? The sun feels eternal because its rhythms are predictable. Sunrise, sunset, the steady arc across the sky. These patterns have shaped human existence since the dawn of time. Ancient cultures worshipped it as a god, a divine force immune to decay. Even today, we speak of solar power as inexhaustible, of daylight as a guarantee. Yet beneath this comforting facade lies a truth that chills the soul. The sun is a star, and stars die. Astronomers assure us that the sun is stable, midway through its life cycle, with billions of years before its demise. But stability is not invincibility. The sun is a nuclear furnace, a delicate balance of gravity and fusion. If that balance falters, even slightly, the consequences would be catastrophic. Imagine the scenarios. A sudden surge in solar activity, a hyperflare dwarfing any recorded in history, could bathe Earth in lethal radiation. Our atmosphere would shimmer with auroras as satellites fail, power grids collapse, and technology crumbles. Civilization would plunge into darkness, not metaphorically, but literally, as the infrastructure that sustains modern life disintegrates. And that is the mild scenario. The true horror lies in the possibility, however remote, of a premature stellar death. If the sun were to exhaust its fuel unexpectedly or suffer an instability we do not yet understand, it could swell into a red giant far sooner than predicted. Oceans would boil, continents would char, and Earth would become a scorched husk drifting through space. Science tells us this will not happen for billions of years. But science also told us stars die predictably, until we discovered they can explode without warning. What if the sun harbors secrets we have yet to uncover? What if its serene glow masks a ticking clock we cannot hear? The psychological weight of this question is immense. We build our lives on the assumption of solar permanence. Our calendars, our agriculture, our very concept of time, all hinge on the sun's reliability. To imagine its betrayal is to confront the fragility of everything we hold dear. Consider the Carrington event of 1859, a solar storm so intense it set telegraph wires ablaze and lit up the night sky with auroras visible near the equator. If such an event occurred today, the damage would be incalculable. Our interconnected world would unravel in hours. And that was not even close to the sun's full potential. Then there are superflares, eruptions thousands of times more powerful than typical solar flares. We have observed them on other stars, stars not unlike our sun. Could our star unleash such fury? The answer is yes. Rare, perhaps, but not impossible. And in the universe, rare is just another word for inevitable given enough time. This is the paradox of the sun. It is both life-giver and potential executioner. Its energy nurtures us, but that same energy, if unleashed in excess, could annihilate us. We live in the glow of a star that could, in a moment of cosmic indifference, erase our species without warning. In the next chapter, we will widen our lens. The sun is not unique in its capacity for betrayal. Across the galaxy, countless stars harbor the same potential for sudden violence. We will explore the odds, the cosmic roulette that determines whether life thrives or perishes. And we will ask the question that haunts every astronomer: are we living on borrowed time? Cosmic roulette, are we in danger? The universe is a casino, and every star is a spinning wheel in a game of cosmic roulette. The stakes? Life itself. The question that haunts astronomers and philosophers alike is simple yet terrifying: are we in danger? Could a nearby star explode without warning and erase everything we know? To answer this, we must first understand the odds. Our galaxy, the Milky Way, contains hundreds of billions of stars. Most are stable, quietly burning through their fuel. But scattered among them are giants, unstable, volatile, ticking bombs of nuclear fury. These stars are the ones that concern us, because when they die, they do not go gently. They erupt in supernovae, hypernovae, and gamma-ray bursts capable of sterilizing entire regions of space. Astronomers have identified several candidates for near-term explosions. Betelgeuse, the red supergiant in Orion, is one. It looms large in our night sky, a crimson beacon that could, at any moment, detonate with a brilliance rivaling the full moon. If Betelgeuse were to go supernova, Earth would not be destroyed, but the spectacle would be apocalyptic, a light so intense it would cast shadows at midnight, a cosmic firework visible even in daylight. But Betelgeuse is not the only threat. Stars like Antares, Spica, and Eta Carinae lurk in our galactic neighborhood, each a potential harbinger of chaos. Eta Carinae, in particular, is a monster, a hypergiant so unstable that astronomers consider it a prime candidate for a hypernova. If it were to unleash a gamma-ray burst aimed at Earth, the consequences would be catastrophic. Our atmosphere would be stripped away, oceans would boil, and life would vanish in an instant. How likely is this? Statistically, supernovae occur in the Milky Way about once every 50 years. Most happen far from Earth, their fury dissipating across the void. But distance is the key. A supernova within 30 light-years could devastate our biosphere. A gamma-ray burst within 6,000 light-years could trigger mass extinction. And here's the unsettling truth: we cannot predict these events with certainty. Astronomers monitor stars for signs of instability, fluctuations in brightness, spectral anomalies, irregular pulsations. They deploy telescopes across the globe and in orbit, scanning the heavens for clues. Yet the cosmos is a master of deception. Some stars give warnings, others die in silence. A star that appears serene tonight could erupt tomorrow, and we would have no way of knowing until its light reaches us, by which time the damage would be done. This unpredictability is not just a scientific challenge, it is a psychological torment. We crave certainty, yet the universe offers none. We live under a sky filled with loaded dice, and every roll could spell annihilation. The illusion of safety is comforting, but it is just that, an illusion. Consider the Fermi paradox, the question of why we see no evidence of advanced civilizations despite the vastness of the cosmos. One chilling hypothesis is that gamma-ray bursts and supernovae act as cosmic reset buttons, wiping out life before it can spread. If true, then the silence of the stars is not a mystery, it is a warning. So, are we in danger? The honest answer is yes. Not imminent, perhaps, but inevitable given enough time. The universe does not care about our calendars or our dreams. It operates on scales that dwarf human comprehension, and in that vastness, catastrophe is not a question of if, but when. In the next chapter, we will explore the ultimate consequence of this truth, the fragility of civilizations in a universe governed by chaos. We will ask whether intelligence can ever truly conquer randomness, or whether we are all just temporary sparks in an endless night. When stars die, civilizations die. The death of a star is not just an astronomical event, it is a cosmic judgment, a silent verdict that can erase entire worlds and civilizations in an instant. When we speak of supernovae and gamma-ray bursts, we often imagine distant fireworks, spectacular but harmless. Yet for any planet orbiting near these stellar titans, the end is absolute. No warning, no escape, just annihilation. Consider the implications. Life, as fragile as it is, depends on stability, a narrow band of conditions that allow chemistry to flourish. A sudden surge of radiation, a blast of high-energy particles, and that delicate balance collapses. Oceans boil, atmospheres strip away, DNA shatters under the onslaught of gamma rays. In seconds, a thriving biosphere becomes a barren wasteland. Now extend this vision beyond Earth. Imagine alien civilizations scattered across the galaxy, each nurturing its own dreams, its own art, its own science. They build cities, write epics, gaze at their stars with the same sense of permanence we feel. And then, without warning, their sun erupts in fury. Entire cultures vanish, their monuments reduced to dust drifting through interstellar space. This is not speculation, it is inevitability. The universe is vast, but it is not benign. Catastrophic stellar events are woven into its fabric. Supernovae occur regularly. Gamma-ray bursts, though rarer, are devastating beyond measure. If intelligent life exists elsewhere, it lives under the same sword of Damocles that hangs over us. Could this explain the Fermi paradox, the haunting silence of the cosmos? Perhaps civilizations do arise, but they are snuffed out before they can spread. A gamma-ray burst within a few thousand light-years could sterilize entire sectors of the galaxy, resetting the evolutionary clock. In this light, the absence of alien voices is not a mystery, it is a tombstone. The philosophical weight of this truth is crushing. We imagine progress as linear, inevitable, a march toward greater complexity and understanding. But what if the universe enforces impermanence? What if intelligence is not a triumph, but a temporary flicker in an endless night? History offers sobering parallels. Human civilizations have fallen to floods, plagues, and wars, local catastrophes that rewrite destiny. Scale that up to the cosmic level, and the fragility becomes unbearable. A species might master energy, conquer disease, even transcend biology, and still be helpless against the death throes of a nearby star. This fragility breeds existential dread. It forces us to confront questions we would rather ignore. What is the point of striving if annihilation is inevitable? Does meaning survive in a universe that erases its own creations? Or is the pursuit of meaning itself the defiance, the rebellion against chaos that defines consciousness? Yet amid this darkness, there is a strange beauty. The elements that make life possible, the carbon in our cells, the iron in our blood, were forged in stellar deaths. We are the children of catastrophe, born from the ashes of ancient suns. Perhaps this is the universe's paradox. Destruction and creation are not opposites, but partners in an eternal dance. Still, the danger remains. Somewhere, even now, a star may be collapsing, its final scream racing across the void. If that scream intersects our world, everything ends. And we will never know why. In the next chapter, we turn inward, not to the stars, but to ourselves. How does the human mind cope with this knowledge? How do we live, love, and dream under a sky filled with silent threats? The answer lies in psychology, in the fragile architecture of hope that sustains us against the backdrop of cosmic indifference. The human mind versus cosmic chaos. The human mind is a fortress built against chaos. From the moment we became aware of the cosmos, we sought patterns, meaning, and permanence. We charted the stars, named the constellations, and wove myths to explain their eternal glow. But beneath this architecture of certainty lies a truth we cannot escape. The universe is unpredictable, and its unpredictability terrifies us. Why does randomness provoke such fear? Psychology offers an answer. Our brains evolved to anticipate danger, to impose order on a world of uncertainty. Predictability is survival, chaos is death. When we gaze at the night sky, we see stability, a celestial clockwork that reassures us of continuity. Yet science shatters that illusion. Stars die without warning. Galaxies collide. Black holes devour suns. The cosmos is not a sanctuary, it is a storm. This knowledge breeds cognitive dissonance. We cling to rituals, religions, and philosophies that promise permanence. Ancient cultures imagined gods steering the heavens, their will ensuring cosmic order. Modern societies place faith in science, believing that equations can tame infinity. But both are coping mechanisms, a shield against the abyss. Consider the role of religion. Across millennia, faith traditions have portrayed the stars as divine, immutable, eternal. They offered narratives that soothed existential dread. The universe has purpose, and we are part of a grand design. These stories were not mere superstition, they were psychological lifelines. In a cosmos that erases civilizations with indifferent violence, meaning becomes a survival tool. Science, too, serves this function. We celebrate our ability to predict eclipses, track comets, and model stellar evolution. These triumphs feed the illusion of control. Yet the unpredictability of supernovae and gamma-ray bursts reminds us that control is partial at best. The equations we worship cannot foresee every catastrophe. This tension, between the desire for certainty and the reality of chaos, shapes culture. It drives art, literature, and philosophy. Poets romanticize the stars as eternal lovers, philosophers wrestle with impermanence, filmmakers conjure apocalyptic visions that mirror our subconscious fears. Even our technological ambitions, colonizing Mars, building space habitats, are attempts to outwit randomness, to carve islands of stability in an ocean of uncertainty. But can we ever truly escape cosmic chaos? The answer may be no. The universe operates on scales that dwarf human comprehension. Catastrophe is not an anomaly, it is a feature. To live is to exist under a sky filled with silent threats. This realization can paralyze, or it can liberate. Liberation comes when we accept fragility as fundamental. Meaning need not depend on permanence. A star's death does not negate the beauty of its light. A civilization's impermanence does not erase the significance of its art. Perhaps the rebellion against chaos lies not in denial, but in creation, in building, loving, and dreaming despite the certainty of annihilation. Psychologists call this terror management theory, the strategies we use to cope with mortality. Some seek immortality through legacy, art, science, monuments. Others embrace transcendence through spirituality. All are responses to the same truth. We are temporary sparks in an indifferent cosmos. And yet, there is wonder in this fragility. The fact that consciousness can arise in a universe governed by entropy is miraculous. We are the cosmos contemplating itself, aware of its own impermanence. That awareness is both curse and gift, a source of existential dread and profound meaning. In the final chapter, we will confront this paradox head-on. We will ask what it means to live under the shadow of cosmic unpredictability, and whether acceptance can transform fear into awe. The universe's silent threat. We have journeyed through the anatomy of stars, the violence of their deaths, and the psychological tremors that ripple through the human mind when confronted with cosmic chaos. Now, as we stand at the edge of this exploration, one truth looms larger than all others. Permanence is an illusion. The universe is not a sanctuary of stability, it is a theater of unpredictability, and we are actors unaware of the script. Look up at the night sky. Each point of light seems eternal, a beacon of constancy in a world of flux. But behind that glow lies fragility. Stars are not immortal, they are ticking clocks, their lifespans measured in millions or billions of years, a blink in cosmic time. And sometimes, those clocks stop without warning. This realization is more than scientific, it is existential. It forces us to confront the architecture of our hopes, the scaffolding of meaning we have built upon the assumption of continuity. We plan for tomorrow, for decades ahead, for futures that stretch into centuries. Yet the cosmos reminds us that tomorrow is not guaranteed. Not for us, not for Earth, not for the sun that cradles our existence. What does it mean to live under such uncertainty? Some will find terror in this truth, a paralysis born of helplessness. Others will find liberation, the freedom to create, to love, to dream without the burden of eternity. If nothing lasts, then every moment matters infinitely more. The fragility of existence is not a flaw, it is the essence of beauty. Stars die, and in their death, they forge the elements that make life possible. Catastrophe and creation are not opposites, they are partners in the cosmic dance. We are the children of supernovae, the heirs of stellar chaos. Our blood carries the iron born in ancient explosions, our bones are built from the remnants of forgotten suns. And yet, the danger remains. Somewhere, even now, a star may be collapsing, its final scream racing toward us at the speed of light. If that scream intersects our world, everything ends. No warning. No escape. Just silence, and then nothing. This is the haunting question we leave you with. What if tonight is the night? What if the illusion shatters while you sleep, and the sky you trusted becomes a weapon of annihilation? We cannot predict it. We cannot prevent it. But we can choose how to live in its shadow. We can choose wonder over fear, creation over despair. We can look at the stars, not as promises, but as possibilities, and embrace the fragile miracle of consciousness in a universe that owes us nothing. So, when you step outside tonight and gaze at the constellations, remember this: they are not eternal. They are stories written in fire, destined to end. And that ending, whenever it comes, will be both tragedy and triumph, a reminder that even in destruction, the cosmos creates. Live as if the stars could explode tomorrow. Because they can. And in that uncertainty lies the most profound truth of all. Meaning is not found in permanence, but in the fleeting brilliance of existence.